Alright, now that we know how to represent negative numbers, let's see subtractions with binary numbers. And subtractions are done by using either 1's complement or 2's complement. Let's look at 1's complement. Let's say that I want to do 10 minus 7, which the answer is 3 in decimal. The first thing that you're going to do is to represent the binary number of these decimal values. So I get 10 and 7. And now you're going to represent the 1's complement of that negative number. And the 1's complement is done by inverting all the bits from your number. So if I apply that, I get this value. And now you're just going to add your positive operand to it. And you're going to get as an answer this value. Now we need to pay attention here. When we apply or when we do subtractions in base 10, our result, it's never a value bigger than the operands. The same thing applies for your binary numbers. Notice that here I have 5 bits and I can only use 4 as my answer. So this is going to be my answer. However, what you're going to do in 1's complement is you're going to pick up that last one and you're going to add to your initial result. And this is going to be your final answer. If we confirm, here you go, you get 3. And this is called end around carry. It's an operation that you need to do when you apply the subtractions with 1's complement. If you have a 0, you can apply exactly the same thing. It's just that it's not going to alter your initial result. Let's go over 2's complement. The same value, 10 minus 7. I represent the binary numbers. And now I'm going to represent the 2's complement of my negative number, which is the 7. Different ways of doing these. You either apply the first complement and add 1, or you can apply the shortcut where you go from the least significant bit until you find a 1 and invert the rest of the bits. And you get this value. I add the first operand, I apply the addition, and you get this as an answer. Same thing applies here. Your answer needs to have 4 bits. Now an advantage of the 2's complement is that you can ignore that last bit and just use the 4 bits in this case as an answer. And you get always the right answer. So no need for that extra end around carry for 2's complement. Let's go over another example. Let's go back to our 1's complement. And now let's say that I want to perform 7 minus 10, which the answer should be minus 3. And I'm representing these in decimal for now. So how do I do it? Let's apply the same steps. So 7 in binary 0, 1, 1, 1. 10 is going to be 8 plus 2. And my answer needs to give me 3 in 1's complement. So what will be my answer right now? Well, let's keep developing our subtraction here. The first thing that I'm going to do is apply the 1's complement to my minus 10. So I keep my 7. And I'm going to flip the bits of my 10. And I'm going to add. And I get 1, 1 gives me 0. 0 carries 1, 1, 1, 0 carries, goes 1, carries, and 1. And now the question is, how do I know that this answer is correct? Well, I know that my value needs to be negative because I have minus 3 over here on my answer. And I do have that as a negative value. If I go to my number, notice that my most significant bit is 1, so this is representing a negative value. But is it minus 3? Well, let's apply the first complement. Let's apply the reverse to this one. So I'm going to reverse all the bits and I get 3 as an answer. So that's correct. This value over here is minus 3 in 1's complement, because when I apply the first complement to that, I get the number 3. It seems confusing at first, but again, just think about the 1's complement. You can use it to transform a positive number to negative number, and you can always transform a negative number to a positive number to validate which number are you representing. Let's do the same thing now for the 2's complement, and I'm going to apply the same one. 7 minus 10, which needs to give you minus 3. These are decimal numbers. So 7, I already know this is my number. 10. Alright, now we're going to apply my 2's complement to my negative number. And my 2's complement, I'm going to apply the technique going from the least significant bit until I find my first one, which is this, and then I flip the rest of the bits. So 0, 1, and I keep those ones. And now I apply the addition. 1 plus 0 gives me a 1. 1, 1, 0 carries. 1 carries and 1. How do I know that this is representing minus 3 in 2's complement? Well, let's apply the 2's complement. I'm going to maintain the bits until I find the first one, which is this one, and then I flip the rest and I get a 0, 0, 1, 1, and here you go. You get 3. So this number is minus 3 in 2's complement.